All right, in lesson 48, we're going to look at a special situation where we have a big right triangle. And you're going to see this. You're going to see this. You're going to have a big right triangle, and then you're going to have an altitude drawn. One altitude. We've talked about altitudes, okay? An altitude is a segment drawn from the vertex to another side, and it's perpendicular. We've constructed altitudes, right? All right, we've done this. So there's an altitude, and if you have perpendicular, that makes it an altitude. Now, what happens when you have this drawn is this. You see the picture right here. I blew it up nice for you. There are a bunch of pieces, okay? There is A, which is the leg, okay, which is the leg of the triangle. And then we have B, which is another leg of the big triangle. And then we have C, which is the hypotenuse of the big triangle. Got it? So we have ABC, leg, leg, hypotenuse. Then we have the altitude. The length of the altitude we're going to call H. Okay, we're going to call it H in this lesson. Now, they could call it whatever. We don't know what it's going to be, but in this lesson, it's H. And then the two pieces of the hypotenuse, there's a smaller piece and a longer piece of the hypotenuse. We're going to call those X and Y, because that hypotenuse, C, is broken up into two pieces because the altitude is going to break it up into two pieces. And there's a shorter piece and a longer piece. We're going to have X and we're going to have Y. All right, so very important to understand those pieces. There is a relationship with these pieces. It turns out that these sides are proportional. X is to H, X is to H, as H is to Y, as H is to Y. X is to H as H is to Y. Now, there's a reason why, and I think when we try to get into the reason why, it just gets confusing. But X is to H as H is to Y. Now, if you cross multiply here, like we have for every other proportion we've done, right? Look what you get. You get H times H, which is H squared, equals XY. This is called a geometric mean. It's a geometric mean because what you could do now is you could take the square root of both sides, and that will give you H. It will help you solve for H because H is squared. As long as H is squared, which it will be because of this, you are able to solve for H. So we're going to use what's called a geometric mean to solve for H. Now, another situation is, same thing, everything's exactly the same, identical picture, except now we're going to look at the proportions that involve A and B instead of H. Let's say we wanted to find A, right? Well, the proportion is X is to A as A is to C. So now to find A, we need the shorter, or the closer, I shouldn't say shorter, the closer hypotenuse segment to the entire hypotenuse. X and C are used to find A. If we want to find B, the other leg, it's this hypotenuse segment, Y times C. Okay? And that's what happens down here. So it's X is to A as A is to C, and that creates, again, cross multiply. You get A times A, which is A squared. Cross multiply, you get XC. So A squared equals XC. And then same thing, Y is to B as B is to C. B squared equals YC. So we're going to use, instead of using the proportions, we're going to use the geometric means. But I want you to know where these means are coming from. They're just coming from proportions that are created by the altitude drawn to the hypotenuse. So this is a very specific situation. Altitude is drawn to the hypotenuse of a right triangle. Here are the three geometric means. So here it is. AB squared, okay, AB squared is going to equal AD times AC. AD times AC, that's the whole piece. And that's exactly what we just said above, okay? Only they use the letters A, B, C, X, Y, and Z. All right? No, A, B, C, X, and Y, and H, sorry. And then there's another one, BC squared is going to equal DC times AC, DC times AC. And right now, I think it's hard to see because these are just formulas. It's very, very difficult to see just looking at this page. I think when we get into actually do the problems, it's going to be a lot better for you. All right, so let's apply these three geometric mean relationships to solve problems. So the first geometric mean relationship, and these are already done for us. So let's say we want to find x. To find x, because it's a leg, you got to look at the big right triangle. Here it is. There's the big right triangle. X and Z are my legs, the way they labeled them here. Okay, so it's different from the X, Y, and Z on the front page because they may change it up. It's the position that it's in. So here is X. This is a leg, and this is going to be equal to 4 times the whole hypotenuse, which is 13. So it's going to be x squared equals 4 times 13, which is 52. And the square root of 52 is 2 radical 13. So this is already done for us, and that's going to make it a little bit easier to reference later on. Right now it's kind of tricky. I want to skip down to this example here, number 4, the first one that we actually have to do. And I'm going to do 4 and then 2 on the next page, and that's going to help you out a lot. So we have x, y, and z. This time x and z are the legs, and then y is the altitude. So the first thing we're going to do is we're going to find x. X squared equals, you take the closer hypotenuse piece, which is 6, and then you multiply by the entire hypotenuse, the whole thing, which is 30. See how it's 6 and 24? The whole thing is 30. So again, x squared, the leg, when you're doing the legs, it's the leg squared equals the closer hypotenuse segment times the whole hypotenuse. 6 times 30. So then we solve that. X squared equals 180. And then we take the square root of both sides. X equals the square root of 180. Now, radicals, you learned this in Algebra 1. Radicals can be simplified. We can break down 180, and we can break it down. And if you're having trouble with this, I can help you in class. But you can break this down to radical 36 times radical 5, because 36 times 5 is 180. And then radical 36 is just 6, and then radical 5 stays where it is. I don't know if you remember doing that in Algebra 1, but that would be your final answer. 6 radical 5, because the square root of 36 times 5 is 180. The square root of 36 is 6. All right, that's going to be our x. Now we're going to find y. Now y is a altitude. Y is the altitude. To find the altitude, it's altitude squared equals, and now you don't add the pieces, you do the pieces individually. The two hypotenuse pieces individually, you multiply those. 6 times 24. Y squared equals 6 times 24 is 144, and then the square root of 144 is just 12. So we know that y equals 12. That means the length of the altitude is 12. All right, and now the last one, we're going to do z. So z squared equals, here's z. Z is the last leg. And to do the leg, again, you got to use the closer hypotenuse segment times the entire hypotenuse. So it's going to be 24 times the whole thing, which is 30. Again, these aren't bad. You're just going to take some practice. I think the more we do them, the better we're going to get. So 24 times 30, which is 720. Take the square root. So it's square root of a 720. We're not going to put that in our calculator. Instead, we're going to try and break up 720. We could break it up 144 times 5, and I did this ahead of time to save you time. 144 times 5 is 720, and the square root of 144 is 12. So this is 12 radical 5. 12 radical 5 would be z. Z equals 12 radical 5. All right, 2 more here. Another one that's pretty straightforward. X squared equals, and again, that's a leg, so it's going to be closer hypotenuse segment times the whole hypotenuse. It's going to be 8 times 16. All right, 8 times 16 is 128. And I did this ahead of time. Square root. 128 breaks down to 64 times 2. And 64 is 8. Square root of 64 is 8. And then radical 2 stays where it is. If you're not sure on the simplifying of these radicals, again, that's an older topic that we're just reviewing now. So I'm going to have to help you with that in class. Next one, we're going to find y. So y squared, that's the altitude. For the altitude, we use the two pieces. So it's going to be 8 times 8. So y squared equals 64. And obviously the square root of 64 is just 8. So there's no radical there. It's just 8. And the last one, z squared is 8 times 16. It's the same as the other one. It's the same as this one right here. So we already know the answer is going to be 8 radical 2. It's the exact same setup, so obviously it's got to be the exact same answer, okay? Now, number 6 is a little tricky in that they're missing information. Sometimes if you're missing information, you can use other things that we know, like the Pythagorean Theorem. When you're dealing with right triangles, always use the Pythagorean Theorem if you know two sides of the right triangle. So here, see this right triangle here? I'm going to outline it. Actually, I'll just color it in. This right triangle here, guys, that is a right triangle because this is an altitude, and an altitude is perpendicular, so it makes a right triangle. I'm just going to pull that little triangle, the one I just highlighted there. I'm going to pull that out and take a look at it. Here's the right angle. This is 3, and this is 9, and this is z. See that? Well, if this is 3 and this is 9, 9 is the hypotenuse of this little triangle, so I could just do the Pythagorean Theorem. So it's going to be, Pythagorean Theorem on this guy right here is going to be z squared plus 3 squared. Again, we're not using the geometric mean. We're going to do Pythagorean Theorem to find z equals 9 squared. This is going to be z squared plus 9 equals 81. Subtract 9. Z squared equals 72. Take the square root. And of course, this breaks down to 36 times 2. 36 is 6. Square root of 36 is 6. That's going to be 6 square root of 2. So it's going to be 6 square root of 2. And that's z. So now I know z. So now I can do x, because x is going to be based on z. I know z. I know the altitude is 6 radical 2. All right, so now I can do z squared. I can do my geometric mean. Z squared equals 3 times x. Should I change colors? Z squared equals 3 times x. So after you do Pythagorean Theorem, you will then go and do the geometric mean. Z squared equals 3 times x. Got to know the relationships. Now, we know z. We can't have z and x, but we know z. Z is 6 radical 2. So it's 6 radical 2 squared equals 3x, and we just solve for x. This is going to be 36 radical 4. Radical 4 is 2. 36 times 2 is 72. And then divide by 3. And x is going to be 24. X is 24. Last one. Because now that we know x is 24, now we can find the other leg of the original right triangle using a geometric mean. Y squared equals 24 times the whole hypotenuse segment, which is 27. 24 times 27. Remember, closer hypotenuse segment times the whole hypotenuse. So this is y squared equals 648. Take the square root, y equals square root of 648, breaks down to square root of 324 times square root of 2, and the square root of 324 is 18. So this comes you. This one gives you 18 radical 2. And we are done with that one. I want to do one of the group work because we didn't do one exactly like this in class, but basically they're saying determine the geometric mean. So if you're doing the geometric mean, you're just going to say x squared equals 4 times 9. The geometric mean is the multiplication and then the square root. So square root, 4 times 9 is 36, right? What's the square root of 36? 6. This is 5 times 20, so x squared equals 5 times 20, which is 100, right? And then square root, so the geometric mean would be 10. The geometric mean would be 10. The geometric mean of 5 and 20 is 10, because when you multiply them and then take the square root, you get 10. All right, so that's how you're going to do those tomorrow in class. I'll see you then.